You know, for all of human history, we've looked up at the stars and just wondered. But what if something was looking back? Not an alien, but a giant rock on a collision course with our planet. Well, today we're diving into the incredible real-world plan to defend Earth from exactly that.
It's maybe the biggest question we ask, right? Are we alone? But there might be a more pressing question. In a solar system that's just full of ancient debris, are we safe from it? And believe it or not, for the first time in 4.5 billion years, the answer might actually be yes.
Okay, so let's get into the nitty-gritty. This is not science fiction. We really do live in what's basically a cosmic shooting gallery. You can see here we get hit by smaller, sort of house-sized objects maybe once a decade. But look way over on the right. Those are the kilometer-plus civilization enders. Thankfully, those are incredibly rare. The real sweet spot for concern is, well, everything in between.
So, to really get the plan, we first have to understand the problem. What exactly are we up against?
Well, scientists have tagged about 40,000 asteroids whose orbits bring them into our planetary neighborhood. We call them near-Earth objects, or NEOs. Just think of it as a bunch of cosmic traffic that keeps crossing Earth's lane on the solar system highway. And out of those, an estimated 25,000 are bigger than 140 meters. Now that's big enough to wipe out a city or cause some absolutely devastating regional damage. That's really the size that planetary defenders are most worried about. Now, here's what's so fascinating, and honestly, a little terrifying. Look at that gap in our knowledge. We've only found about 42% of those really dangerous objects. That means more than half of them, the majority, are still out there, completely unseen, flying around in the dark.
And look, this isn't some theoretical threat. Back in 2013, an asteroid we never even saw coming exploded over Chelyabinsk, Russia. The shockwave shattered windows all over the city and injured 1,600 people. It was this huge wake-up call that even the smaller ones that we miss can do some serious harm.
So, with a threat this big and this real, what's the plan? Well, thankfully, the world space agencies aren't just sitting around waiting. They've got a playbook.
Now, at first glance, I know this looks really complicated, but NASA's entire strategy, the whole thing, really boils down to a clear, logical process. So let's break it down into its core parts.
It really just comes down to these three crucial steps. It's so simple when you think about it. First, you have to find them. Second, you have to predict their path with incredible accuracy. And third, well, if one's headed our way, you gotta stop it.
Right. So this is the most crucial part. You can't stop what you can't see. Step 1 is basically this monumental game of cosmic hide-and-seek.
Our eyes on the sky are this amazing network of powerful ground-based telescopes, like Pan-STARRS in Hawaii and the soon-to-be-online Vera C. Rubin Observatory in Chile. Every single night, they are just scanning the darkness, looking for these tiny, faint points of light moving against the backdrop of stars.
But see, telescopes on the ground have a big blind spot. They can't easily see asteroids coming from the direction of the sun. The glare is just too much. And that's where the NEO Surveyor comes in. This is a space-based infrared telescope that's going to hunt for these hidden threats from a perch out in space. It's going to totally revolutionize our search.
And this just shows you the impact perfectly. Just look at that jump. With our current surveys, we're on track to find just under 60% of the asteroids we're looking for. Okay, add the new Rubin Observatory, and we get to about 75%. Not bad. But then you bring in NEO Surveyor, and we leap to nearly 95% completeness. We'll finally have a near-complete map of the hazard.
Okay, so let's move on to step 2, because finding an asteroid is really just the beginning. The next, incredibly difficult challenge is predicting exactly where it's going to be decades or even a century from now. To meet that challenge, NASA brought this powerful new tool online in late 2021. It's called Sentry-2. Think of it as a next-generation automated system designed to calculate the impact risk for every known asteroid with a precision we've just never had before. So, the original Sentry system was good, but it had its limits. For really tricky cases, it needed a person to come in and do time-consuming manual analysis. Sentry-I, it's a complete game-changer. It is fully automated, and crucially, it can model a very subtle but incredibly important force that the old system just couldn't handle. And that force is called the Yarkovsky effect. The easiest way to think of it is like a tiny, solar-powered rocket engine. As an asteroid rotates, it soaks up sunlight, and then it radiates that energy back out as heat.
This creates a minuscule but constant push that, over decades and decades, can significantly change its orbit. Sentry 2 actually accounts for this, which makes its long-term predictions so much more reliable.
So, we've found it. We've predicted its path, and oh no, it's on a collision course. Now for the main event. How do we actually stop it?
Well, our primary, and now proven, defense is something called a kinetic impactor. Now, the idea isn't to blow the asteroid up, like you see in the movies. It's more like a game of cosmic billiards. You crash a high-speed spacecraft into it to give it a tiny, tiny nudge, changing its path just enough so that years down the line, it sails right past Earth.
And this is the amazing part. This is not a theory anymore. In 2022, we actually did it. NASA's DART spacecraft traveled millions of miles and slammed into this little asteroid moonlet named Dimorphos. I mean, this was the moment humanity first pushed back against the cosmos.
And the result? It was a spectacular success. The impact changed Dimorphos's orbit by a whopping 33 minutes, which just blew away expectations. We now know for a fact that if we have enough warning time, we have a viable way to defend our planet.
Now, the DART mission was a massive triumph, but it wasn't just one country's achievement. And this brings us to a final, absolutely crucial point. Planetary defense, it's a team sport.
An asteroid doesn't care about borders, right? So our defense can't either. You have these groups like the International Asteroid Warning Network that coordinate observations from all over the globe, and the Space Mission Planning Advisory Group getting all the space agencies on the same page for a response. Even DART itself was a team effort, with an Italian satellite companion and a European follow-up mission called Hera. This is truly a global shield in the making.
So when you think about it, for the first time in Earth's long, long history, the fate of the dinosaurs doesn't have to be our own. We have the tools, we have the plan, and we've proven it works. The question is no longer if we can defend our planet. The question is, will we be ready when we have to?